Engineer versus Designer is brought to you by the Mojo 3D printer. Now you can have 3D printing right at your desktop at a remarkably low cost. With the magic of Mojo, there's really no limit to your creativity. See it at mojo3dprinting.com.
Well, Josh,
yes.
As you know, this week we had an opportunity to sit down with the one and only Mike Leydet of College Park Industries.
Yes, indeed. He makes, cool. Can you believe it, prosthetics out there. It's really interesting work, inspiring kids, and making
grown-ups.
Some pretty cool stuff. And grown-ups, too. Yeah.
Yeah, pretty inspirational stuff. So without further ado, why don't we just jump in?
Jump right in.
Woo! So, Mike Leydet.
Yes.
For Josh's daughter, Isa, who is about 4 years old. 4 years old, listening right now. What do you do?
Well, sometimes people are born without feet, and sometimes they have accidents and they lose their feet. And my company, or parts of their legs, and my company gives them an opportunity to walk again. So we make these mechanical feet or foot products that we can put on people and allow them to walk. So in simple terms, we're putting people back on their feet.
That is amazing and such a beautiful thing. Now, do you you're doing more than just prosthetics, though? This isn't just
right.
prosthetics. You guys are doing some pretty sophisticated stuff. What are you doing?
About 6 years ago, we were, as engineers, looking at we were making feet for amputees, and we'd have them walk on them, and they say whether they liked it or they didn't like it. And as engineers, we wanted to put numbers to it. And there was no load cells or force and torque measurement devices that were wireless. So we started to embark on a major program to develop our own wireless load cell. Well, 6 years later, or 5 years later, we finally have the product out on the market. We initially didn't intend on putting it on the market as well. We were developing it for our own internal use. But there was so much money spent in time, and we felt that not only was it an opportunity for us to learn about how to make better prosthetic feet, but in our industry we have somewhat of an altruistic view about the products that we make, and to withhold this technology from our competitors was almost not, it wasn't right. So College Park made the difficult decision to say, hey, we're going to open it up for everybody. Excellent. And we're going to push the industry to a higher level, because currently researchers have never had this device to use. So we're putting it, so now we're selling it to universities, to the VA. We've sold several in international applications. They're using it everywhere from in robotics companies to prosthetic manufacturers, and we've sold them to our competitors.
And this is the IPEX device?
It's the IPEX device, yes. Okay. So it's a 6 degree of freedom force and moments transducer. It's got onboard data logging, so you can have somebody, if you don't want to collect data real time with a computer and Wi-Fi, you can have them walk up a mountainside for 2 or 3 hours and collect all that data and bring it back, and for the first time ever see those forces and moments.
It's analyzing their motion to customize the prosthetic for them, or
right now it's collecting and measuring.
So to put that in lay terms, this is a black box that you can hook onto somebody.
Yep.
So that when you're building their prosthetic limb,
yes,
then you understand better what the forces are, how their leg is moving.
Absolutely.
So you can tune that leg so that it moves the way that it ought to.
Yes, and the original product is the IPEX Lab, and that has more bells and whistles. We are currently developing for launch later this year the IPEX Pro, which is going to be the first clinical tool that does the same thing. It's going to have this not as high resolution as far as the data, but it's going to have what's relevant for a clinician to fit and align a patient in their office. So now a prosthetist is not just using his visual cues and his skill set or her skill set. Now they're also, and also the feedback from the patient, but now they're going to be able to get real hard numbers. And this is something that Medicare, Medicaid, and insurance companies have been asking for, because they've never really seen, well, you fit a patient with a prosthetic device. How do I know you did your job right as far as the alignment process and the fitting process? Well, now we can put hard numbers to that. And So this is
So
the product.
how's that different from the traditional? You explained a little bit that allows you to collect numbers, but are they still? You still have to create a mold, and
You still have to do all of that. Custom fitting a socket to an amputee still has to be done with plaster of Paris or scanning devices that they use today. They'll scan the residual limb, and they'll use NC cutters to cut foam systems that they can take a cast off of for their sockets. So there's systems that are doing that now, but those are the custom components that actually are the prosthetic device.
You're tuning more of the
You're
mechanics
tuning
of
the
the
mechanics,
device
yes.
instead of the fit.
The alignment is so critical because there's so many adjustments you can make. It's kind of like, if you can imagine trying to balance the tires on your car alone in your garage. Years ago, people used to use a chalk mark on the wheel, and they'd spin it up, and they were skilled at balancing tires in a car. Now you drive into a tire place, and they put it on this big machine, and it has diagnostics that balance the tire much better than you could have ever done it by
Right.
eye. That's our intention with this new product. So it's balancing the system, so that when somebody's walking, they can walk with very natural gait patterns.
Now, this is a beautiful thing, and I love the fact that this is open. I love the word open,
Right.
but it means so many things to so many different people. So 2 parts to this question. A, what does openness mean to you in this case? What parts are open? And B, how does that work with your business model?
Well, our business model has been to make mechanical prosthetic feet. We also have, we've worked and dabbled in some bionic feet that we do have some designs for. The market is not quite yet ready for that. The cost of a prosthetic limb currently for mechanical limbs can be anywhere between $10,000 and $50,000. Now throw in all these microelectronic systems and hydraulic systems. Now you're just adding more and more money to the cost of a prosthetic limb. We're also a small company, so we saw that there was a need in the assessment of gait within a clinical setting. So the idea is, if we can help prosthetists do their job better and kind of work on developing the skill sets in-house at College Park so that we can work with electronics. We're designing all of this from ground up on our own. I mean, we hired the engineers, we're doing all of the printed circuit board design. So openness is really, it's two-phase. For a business plan, we're trying to make sure that we've got the skill sets in-house. And while we're developing one product, we're getting ready to develop the next one, and that's going to be the microelectronic control foot ankle device, which is called the iPad. So we've got iPads and
I get it.
iPad. So
Wow, that's not going to be a confusing thing at all.
No.
I'm pretty sure.
No.
So on a personal level, why is this important to you?
Wow. I just get so excited about the fact that we're helping people. I've seen so many amputees put our feet on, and we are a company that makes sure that, matter of fact, our director of special projects is an amputee. We've got several amputees working for us, and we've always put our products on them, because if they don't like it, we're not going to put it on the market. I just talked to a guy about 2 weeks ago, and he's got both of his arms were amputated. He had sepsis, he had an infection. Both of his arms and both of his legs, below the knees, were amputated. And he has such a zest for life, and he recently put on a new product, the Soleus foot. And he got a little choked up, and I did too, because he said, for the first time, I can walk and do whatever I want on any surface, any terrain. And think about it, he doesn't have arms he can throw out to break his fall. And he's walking on 2 mechanical legs, and he's walking over gravel, dirt roads. He's walking up basically hiking trails in Arizona, and he's just so enthused about this new product and the fact that it doesn't make him tired. See, if you're on a prosthetic limb that has a lot that's not working correctly with your body, it causes a mental and physical strain. A good example, I love this example, that was my phone, is if you've ever gone into a grocery store and you grab that cart it's got the banged up wheel. It's either rusted up or it's wobbly and it's noisy. So if you take that cart and you walk around that store, it's making squeaking noises and you're feeling a little bit.
You're all stressed out by the time you get to the front.
And then when you start loading it up, it's hard to push around the
yell
end
at
of
the
every
clerk
line.
when you get in the line. It's not pretty.
It's the same thing with a prosthetic foot for somebody who's an amputee. If they've got a foot that's either not properly aligned or it's not working with them well as far as its ability to function properly for their needs, then they're constantly hitting that wall. And sometimes they can be noisy too. So these are the things that when you make a product and a good design and you see it work and you get that kind of feedback that this is by far the best product they've ever walked on, it just makes you feel like you've really done something important. And I believe that can be for any product, maybe even for the grocery cart manufacturers of the world. If you can make one that doesn't get all rusty and it's funny, I've used this analogy several times, and just recently I was at a Kmart and I grabbed one of those carts and I started walking with it and I go, no, not me, not this time, and I pushed the cart back and then I went on grocery shopping, and in about 5 minutes later, I heard squeak, 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 squeak. And I thought, oh, somebody grabbed that cart.
Problem on to somebody else.
I should have taken it.
How do you feel about it? You should have taken that.
I got a good chuckle out of it.
So, Mike, how did you get into this personally? How did you start with this company?
I started. There's a little story about. I worked in corporate America for a company called Eaton Corporation. And I worked with a great group of I worked at a research center for 15 years. It was like I started there when I was 18 years old. And I have a lot of I'm very thankful for the company that I worked for. But as I got older, I started going, well, I want something more. And I put my resume out there, and I wanted more money too, but that didn't happen. But I did go in and put my resume out, and I was lucky to be interviewed by my former Director of Engineering, Chris Johnson, who was an amputee. And I liked the fact that he took me out for a beer for my job interview, and I thought, well, this is a little bit more laid back than I was used to in corporate America. So we were at, I think we were at a Bennigan's, and he was sitting there, and I noticed that he was an amputee, and he had his hand all bandaged up. And he was talking about how he was getting older and feeling, kind of achy. And I said, I'm kind of feeling that too as I get older. And he goes, yeah, he says, he made the comment that, he was really feeling kind of, I'm trying to remember what he said, something to the effect that turning 40 was really getting tough for him. And I looked at his arm and I looked at his feet and I said, you better be worrying about 50. And he laughed.
Oh, fortunately.
And,
that's
for some reason he hired me, and he's been a good mentor, and I've had a lot of them at College Park, just a good group of people, and very dedicated engineering staff and technicians and people out in the plant that take pride in their work.
How different is what you're doing from engineering another kind of product, a washing machine or a laptop or anything else? I mean, is this straight ahead engineering work that you're doing,
Yes,
or is
it
this
is.
in some ways different? Or
I would say, the biomechanics are different, and I think that.
I would think that working with a human being in such an intimate way would be different somehow.
The one thing that really shocked me when I first got involved in this industry was when you're talking about automotive or heavy truck, everything's linear or rotational. When you talk about the human body walking on a foot, everything's linear and rotational, all at the same time. So all of those statics and dynamics classes that you should have paid more attention to in school really come into play. And it's overwhelming. The human body is incredibly tough on prosthetic products. The type of abuse that they get are tremendous. We can have a foot that lasts, it's gone through all of our ISO tests, and it'll last for 10 years on most people. But you put it on a 14, 15-year-old child who's taking two sports in high school, and he's going to destroy it in 6 months. And there's nothing you can do. you're trying to provide a highly functional, lightweight prosthesis for this child, as you would for the adult that's going to be wearing it. And they're just going to abuse it at a level that you cannot keep up with. And if you try to make it stronger for them, it'll be restricting the motion, restricting the function, because it'll be heavy, it'll be not as dynamic. So these are the things you're always balancing. How much...
Well, I would think it would also be, it's a highly customized product,
It
right?
is.
It's not like you're mass producing these, or at least not in the conventional sense. You're making them specifically for an individual.
Yes.
And highly tailoring them for that. It
Well,
just seems like that would have its own challenges.
The True Step foot has over 144,000 configurations.
Wow.
We create a modular design, and we have different bumpers and different bones and bushings and things like that provide different durometers of flexibility in the system. The True Step foot, by the way, is going on its 22nd year being sold. Yeah, we've had many design upgrades, but it's got a product lifespan that, like no other product I've ever known, and it's still a very popular product for College Park. It's actually what built the company. That foot, it's in these 144,000 configurations are legitimate configurations for build.
Wow.
So what we do is we get the phone call in the morning or during the day. We take down certain biometric aspects of that individual, their weight, their amputation level, because if they're above knee amputee versus a below knee amputee, you have to take that into consideration how you build the foot. And then we have what we call a gait match. That gait match is a program that we put all the information in based on it's like how long is the residual limb as well. All that information goes into the system, and then we get how to build it prints out a bill of materials for us to build the foot that day. So we build and ship same day.
Same day.
Yes.
It's incredible.
Wow.
We've been doing that for 22 years now.
And the True Step is at the same price point. You mentioned these can cost anywhere from $10,000 to $50,000.
Now that's for the whole leg.
That's for the whole leg.
That's for the whole leg. In the durable medical equipment arena, the prosthetist does not get paid for the work that he does or she. They get paid for the products that they put on the patient. So if they put this foot plus these what we call endo attachments or mounting attachments, plus they made a socket, all of those components add up to a certain price point. Now, if you have an above knee amputee and you're one of our competitors, Autobach, it makes they made the world's first microprocessor controlled knee back in 1996. Now that if somebody's fitting a microprocessor controlled knee, that's going to have a much higher price break than just the foot. So and our prices vary anywhere between. I can't give you exact prices because that's kind of between us and the prosthetist.
Yeah.
But it's more in the thousands rather than into the tens of thousands.
Now I'm going to take a step back here. You're delivering one of these hundreds of thousands of configurations.
Yeah.
Same day delivery.
Yep.
Unbelievable. Obviously, we might as well get the plug in. We are at PlanetPTC right now. We should just say there's probably a reason you're here.
Yes.
That sounds like that might be part of the story that they would want you to tell.
PTC has been very gracious about this. College Park, for the IPEX lab last year, we won the NASA Tech Briefs Electronic Product of the Year Award. And thank you. It was a Create the Future design competition. And that's how we got involved with PTC. And they've been great. And they've actually asked me to come here to do a keynote address. And I'm following Dean Kamen, which is, no pressure on me. But the main thing is they've told me they didn't want me to really push PTC too much. They want me to inspire people and try to tell the story of College Park, the people that we help. And I've got, and I really respect a company that is willing to have me come here and not just plug them in front of their customers. I think that says a lot about PTC. So maybe I'm taking a little bit different approach. We do use Creo products, if you want to hear that, and we have used them from day one. Now, PTC, we used Pro E originally, and now we're using Creo, and a lot of the organic shapes that we designed for our foot shells, things like that, we wouldn't have been able to do with any other program.
Yeah, so speaking of inspiring kids,
Yes.
we've got a passion for inspiring kids. Talk about making. How are you involved in any of that, and how is College Park trying to inspire kids more?
Well, aside from, I guess, not directly, as far as engineering. I mean, we were the...
Well, you are by being here, you know?
Yeah.
I mean, hopefully people hear your story and they get excited, you know, about
Well,
design and engineering and what you can do to help people, to build into people's lives.
I shouldn't say that we're not doing it directly. I mean, we were the first company to make a multi-axial, high-functioning prosthesis for children. About 10 years ago, the academic researchers in the industry said you have to restrict motion for children wearing prosthetic devices to allow them to have more stability. And we had been making the true step for years and said adults love motion in their ankles, so why wouldn't active children? So we said, nah, that's bunk, and we developed this foot, and now it's one of the most popular prosthetic feet in the market. But we also do presentations at local elementary schools in the Detroit area, so we do that. I forgot for a second, but we have been doing that. And honestly, whenever somebody calls me up and wants to do a tour of the plant, if I can't do it, one of my engineers does, and we're always willing to bring in students from local universities as well as local high schools for tours.
I mean, it's such a fulfilling application of engineering know-how that and building into people's lives in such a real and visceral kind of way that I think it's an excellent candidate for getting people excited about engineering and design. I mean, how can we as a society better foster a love of and an interest in engineering and design in younger people?
Well, I think I mentioned it when we were off mic earlier. I think one of the things that I've heard time and time again, and it makes me kind of sad, is when children say, I'm not good at math, so I can't be an engineer. I'm not good at math, so I can't do this or that. I wasn't that good at math either. And I'm director of research at a medical... Yeah, I know. Don't tell anybody. I'm going to get thrown out of my job. No, I'll tell you, it was a struggle. It didn't come easy. But the reward I'm getting from it now, not just from the great products that we make, but in a time of where the economy is in dire straits, I have a job, I have a skill, and I think people need to put some value in that. You may not be the director of research at some company, but to learn a skill and to be interested in design and being creative shouldn't be something you're afraid of. It should be something that you're predisposed to want in this world. And I think a lot of people, society today doesn't foster that as much. Everybody,
I think sometimes it can for some design students, that I talk to when I teach.
Yeah.
They'll say that some of them, I've literally talked to kids who get out of design because they say, the world has enough plastic widgets in it, and I just don't feel like I need to contribute more of them. And I actually kind of have to say, that's a good point, and I'm glad you came to that decision. But I think people like you are showing us ways that actually, this is vibrant, beautiful stuff that can be built into our society in a much more meaningful way than just more widgets and whatnot.
I work with a group of engineers in my research department. I actually am a mechanical engineer managing electrical engineers and software writers. Now, if that's not a strange combination, I don't know what is. But these guys are so dedicated and love their job so much, they're calling me on the weekend because they had another idea about something else we could do to make the product better. And sometimes I look at the phone ringing and I'm like, oh no. But I answer it. because I know that I'm going to get an excited engineer on the other end of that phone going, hey, we got to do this on Monday because, and this is, and, you know, it's just that excitement. We are working on some other technologies right now that I really am not able to talk about, but I'm telling you, there's so many areas that are untouched that those plastic widgets could be the next great opportunity to save somebody's life or to make somebody's life better. And one of the other messages in my keynote is that whether you're developing software for PTC or whether you're developing materials systems for General Motors or Boeing, those products and those materials may be used later to develop composite feet like they were. We used PTC's Pro Engineer to develop the spring designs and the organic designs of our foot shells. We used Boeing's research in composite materials that was done 50 years ago, 60 years ago, in the development of our springs. So, you know, these people who worked on these technologies, they didn't intend them to be used the way they're being used now. So
Everybody plays a role in one way or another.
yeah, I mean the guy.
As long as you're contributing.
Exactly, and you know, I think that people have to open up their mind to that. That it's not just another plastic widget.
Yeah, that's a good point.
Well, we're about out of time, but one final question.
Sure.
What advice would you give to somebody that wanted to get into prosthetics design?
Be tenacious. It's a small market, but you know, there's so many people with amputations or limb loss, and not everybody who has limb loss had an amputation. That's why I say that. You have to be tenacious. I remember one time I was interviewing several people for this engineering job at College Park, and there was the one who walked in the door unannounced that I hadn't looked at his resume prior to filling the position, and that person was the person that got the job because they drove it down the street, and he walked in the door on crutches because he had just broke his ankle, and he handed me his he filled out a application, and I said, and I had just walked somebody else out the door who I just interviewed, and I was thinking about hiring that guy, and so the guy on the crutches got the job. Not because he was on crutches, because I liked him better and I thought he was better for the job. And he's still working there 11 years later. So be tenacious, but not too tenacious. You know, there's a point.
But not off-putting.
No stalking. No stalking. But definitely, and make sure that you do try to get yourself the correct skill set that fits. Do your homework. Go on the internet. Look at the different companies or products that the companies make, understand the technologies that go into those, the materials and technology. Materials is a big part of it. You got to understand the dough you're making the pizza with. You know, if the dough's bad, the pizza's not going to be good either.
Right.
You know,
right.
So I would say that don't be afraid to fail. I think a lot of people are sometimes. And
absolutely goes along with tenacity really well.
I failed many times in the past, but you got to brush yourself off and keep moving.
Excellent advice.
Mike, thank you so much for your time today. I really appreciate it.
You're welcome.
Thank you very much.
Thank you.
Look out! Engineer vs. Designer is brought to you by Mojo 3D Printer, a world-class professional 3D printer for only $185 a month. To find out how you can give your big idea a little mojo, visit mojo3dprinting.com.
A production of EVD Media.